Hello everyone. This is Dhanalakshmi, Assistant Professor from EEE Department of RMD Engineering College. In this session, I would like to discuss about build process of embedded systems. So in the subject embedded systems, where our unit 1 is all about introduction of embedded systems, where we have how to build how to build or build. It is generally said as build process of embedded system. We'll go into that. So this is the flow diagram of a build process of embedded system, where you can see that we have a source code. This source code will be written in any high level language. So it can be in the C++, right? So it can be in any high level language where the code has been written, that is called as the source code. And after that, the source code is written by the user, where the user will be writing in the high level language. Whereas the machine can understand only the machine code. So what we have to do is the next step of writing a source code that has to be compiled using compiler. And there we have two types of compiler called compiler, and the other one is the cross compiler. Then we have assembler, then we have linker, then relocator, then finally it will be in the form of an executable form, that is executable code. So we'll see one by one. So when the code has been written, which is in the high level language, is said to be a source code. Then it has to be given to the compiler, where compiler is a translator which will translate the high level high level language to a assembly language or a machine code, right? So this compiler will be converting or translating that high level language to a assembly language. And then comes the assembler. The role of the assembler is to convert the assembly language to a machine code, right? So machine code in the form of zeros and ones, right? So therefore, after converting that into a machine code, that will be given to the linker, where that is once at the output of assembler, we will get it in the form of an object file. So this is a source code, source file, and source file, when it is given to the compiler, will be compiled, and that is translated into an assembly language. Then it will be sent to the assembler, where in the assembler it will be converted into a machine code. Then in the machine, after converting that into a machine code, what happens here is so here you can see that once the once the assembly source code is converted into a machine code, finally it will be in the form of an object file, right? And so in the linker, then it is given to the linker, where linker is going to link all the object files into a single relocatable file. So the purpose or the role of the linker is to link, right? To link all the object files into a single file, into a single into a single exa file. Right, that's it is in the form of it's a relocatable exa file, where the address will be assigned to that, and finally it will be in the form of an executable code. So we'll see here. So when we take IDE is the integrated development environment, where these are the things which we have in the IDE, right? Integrated development environment, where the first one will be the code editor, where it's an editor window where you can change, you can write the code, you can change it, so you can do all the changes there. So it's a code editor will be there. Then you can edit all the code, you can edit the code there. So that will be code editor. Then we have the builder. As I said, the builder will be having the compiler, assembler, then linker. So compiler will translate the high level language where the source code has been written in the form of in the high level language, that will be converted into assembly language through the compiler. Then after compiler, we'll be having assembler, where assembler will convert the assembly language to a machine code or machine language. Then it will be in the form of a object file. So initially what we fed is the source code, source file, and that after compiler and assembler, it will be in the form of an object file. And we have many number of object files, and all that object files will be linked with the help of a linker. So finally, after linker, it will be in the form of a relocatable exa file. So that is what it's an executable file where it is stored in the memory. So apart from this builder, we have a simulator, then GUI. GUI is a graphical user interface. So you can see that compiler, as I told, it's a translator which will translate the high level language to an assembly language. Whereas when you take a cross compiler is the one where say for example, we have a PC where the code has been written, where we have the source code, right? Whereas the other one is the embedded board. For example, let me take that for my application. If my embedded board is going to have an ARM processor, whereas in my PC, if I have 8086 processor, this 8086 PC processor will be doing its compilation for the code which has to be fed for the ARM processor, right? So that is what called as cross compilation. That is the target. Code will be translated. The code will be compiled by the PC processor for the target board. So that is what called as cross compilation, right? So this is the thing you can see here. So this is our host is our PC, and this is our target board, that is our embedded system board. Where in the target board or in the embedded system board, for example, let me take for my application, if I'm going to use ARM processor, whereas in my host is our PC, where PC will be having 8086 processor, for example, right? So therefore the 8086 processor, PC processor, will be doing compilation of the code for the target board, where in the target board it is the ARM processor. So for ARM processor, the 8086 processor will be doing its compilation. That's called cross compilation. Right. Similarly, the assembler is the one where it is going to convert the assembly language into a machine code. So again, here also we have assembler and cross assembler. It's very similar to your cross compiler, where for the assembler, the assembly, that is the conversion of assembly language to a machine code, will be done by another processor for the target board. So that is called as the cross assembler. And once this process is over, so you can here see that is a C program. It's our source code, which is written in the high level language that has been compiled here by the compiler. So once the compiler, once the program is compiled, it will be in the assembly language. The source code high level language will be converted into assembly language. Then from the assembly language, it is given to the assembler, where it will convert that assembly language to a machine language. So that's called as an object file. Right. So we have so many number of object files, and all that object files have to be linked into a single executable file, relocatable file. So that is why we have a linker here, which will link all the object files into a single file. And then you can see that after linker, you will get a executable file, and that executable file, which is an exa file, which will be loaded into a memory. So this is how the process of building has been taking place. So you can say then at the end, we'll be having disassembly. That is, once we have assembly here, finally at the other stage, we'll be having the disassembly, where it will be converting the machine language to assembly language. So you can say that machine code, exa code into an assembly language. That is what's shown here. So you can see that exa code is here, where it has been converted to a assembly language. That is move r comma, for example, here it is move r3 comma value of 20, right? So this is the purpose of a linker, where the source code, after passing through compiler and assembler, will be converted into object file. So we have a number of object files, and all the object files have to be linked. That's why we go for a linker. So a linker will link all the object files, and it will make into a convert into a single executable file. Right. So this is the process of build process of an embedded system, where you can see that how the source code has been converted into an object code. So pre-processing, then compilation, linking, and locating. So compilation will be having the assembler also. Compiler, when we say, it is also includes the assembler. So compiler, assembler all together. So where it will convert the source code into an object file. Then the object file is once we got the object files, all the object files have to be linked using the linker. Then once the linker is going to link it, and it will make it as a single executable exa file, that is again loaded into the memory. Right. Thank you.